If you've been watching the news recently, you will have seen that two major reports have been published in the past 18 months, including one just 2 weeks ago that paint a devastating picture of the threats to the world's wildlife. With over 1 million species at risk of extinction and average population declines of 68% over the past 50 years, the need for conservation intervention has never been greater. Today I'm going to talk about the Sihek, one of the many species in the world that's already suffered from massive declines and nearly become extinct. The Sihek, also known as the Guam kingfisher, is a species of kingfisher endemic to the island of Guam, which is really far from UCL where we're supposed to be. The Sihek has been extinct in the wild since 1986, when the last 29 known members of the species were taken into captivity. The Sihek's extinction in the wild was caused by a variety of factors. The accidental introduction of the brown tree snake, thought to have arrived in Guam just after the end of World War II, is a major cause of their decline, as well as the development of the island for agriculture and tourism. As a result of this, Guam was no longer a safe habitat, and no choice remained but to bring the last remaining Sihek into captivity for breeding and species recovery planning to take place. There are over 500 species survival plans currently in place, and a key component of many of them is ex situ species management. Ex situ management can be used to help maintain populations using breeding programs to bolster their numbers in order that individuals can be harvested for re-release into the wild. High-profile success stories that have been the result of ex situ management include the Przewalski's horse, Arabian oryx, and Californian condor. For a population to supply individuals for release, its growth rate must be high enough that harvesting individuals does not damage the population's viability. One way to achieve this is to ensure that the population's reproductive success is high. In birds, reproductive success can be determined by measuring what proportion of eggs laid are fertile, what proportion hatch, and then how many offspring fledge. In highly endangered species, these metrics are often particularly low. I'll now discuss some of the reasons that reproductive success can be low in critically endangered or extinct in the wild species, using the Sihek to demonstrate just how bad it can get. Over the past 34 years, the Sihek population has grown from 29 founder individuals to approximately 135 today. Although there is active recovery planning ongoing, recent research found that the current population size and population growth rate are too low to support harvests of individuals for re-release into the wild. This means that in order to successfully reintroduce the Sihek, we need to understand what is limiting their reproductive success. Reproductive success can be influenced by many factors. In the zebrafinch, the inbreeding coefficient of each parent, or how related their ancestors were, can be a highly influential factor. In the pink pigeon, the kinship coefficient is important. This is a measure of the relatedness of two parents to each other. In the whooping crane, both male and female age are known to affect reproductive success, and in the pied flycatcher, difference between parents' ages can also have an impact. Finally, the position of an egg in its sequence, both within a clutch and across a season, can impact its success, as some birds, including the lesser snow goose and blue-footed booby, invest differently in eggs of different positions in those sequences. So how do these factors affect reproductive success in the Sihek? To find out, I first quantified fertility and hatching rates before investigating what role the factors of parental age, inbreeding and lay order play in determining how high or low they are. Using fertility and hatching data retrieved from 9 out of the 24 institutions that house Sihek, a total of 315 eggs were used in my analysis. Of these 315, only 134 were fertile, giving a fertility rate of 43%. Of these fertile eggs, only 88 hatched, giving an overall hatching rate of just 28%, or a hatching rate of fertile eggs of 66%. In different terms, of the 42 pairs that contributed to the dataset, only 17 managed to hatch at least one offspring. As I mentioned before, low reproductive success is common in critically endangered birds, but very rarely is it as low as this. When compared to other birds that have gone through similar population declines, Sihek fertility and hatching success rates are exceptionally low, with other highly endangered birds, such as the takahe and kakapo, both maintaining fertility and hatching success rates far higher. With this knowledge, I wanted to work out why these rates were as they are. With recent research finding inbreeding to be very high within the Sihek, looking at parental inbreeding coefficients was a good place to start. I used generalized linear mix models, or GLMMs, to investigate the effect of sire inbreeding coefficient, dam inbreeding coefficient, and the pair's kinship coefficients on fertility and hatching success. In the fertility model, I used each pair's unique ID as a random effect to account for individual differences, and another random effect to account for changes in Sihek management over time. Neither of these random effects explained any variation in the hatching success model, so both were removed and the model was run as a general linear model instead. Model selection was carried out on the fertility model to retrieve a set of top submodels which then underwent averaging. My results showed that sire inbreeding coefficient significantly affected fertility, with the model predictions finding that the proportion of eggs laid by a pair containing a male with an inbreeding coefficient of 0.1 to be very low indeed. Surprisingly, dam inbreeding coefficient had no effect. No significant relationship was found between pair inbreeding coefficient and fertility, and no significant effect was found between any of these variables and hatching success. The connection between sire inbreeding and fertility is found in other species. Evidence in zebra finches finds that sperm motility is significantly less in inbred males, reducing their ability to fertilize eggs. Finding no connection between female inbreeding and fertility, however, was surprising. Recent research into the Sihek has found that inbreeding depression affects both reproductive success of males and females. The previous study measured reproductive success using number of hatchlings produced, rather than fertility or hatching success as I did. This suggests that although the eggs of highly inbred females may have the same success as eggs laid by their outbred counterparts, the female may lay less eggs altogether. These results are also found in the Takahi, where dam breeding is related to the number of offspring she can fledge, but not the proportion of eggs that hatch. The second relationship I looked at was between parental age and fertility and hatching success. Once more, I did this using GLMMs. I focused my analysis on understanding relationships involving each parent's age and parental age difference, while including dam age as a squared term to investigate any nonlinear relationship. Differences in pair quality and management over time were accounted for using random effects where necessary. Model selection was carried out to retrieve a set of top models, which then underwent model averaging. My results showed that dam age had a significant effect on fertility, with fertility generally declining as dam age increased. Very few eggs laid by females past the age of 8 were fertile. Model selection also found that sire age explained much of the variation, but this relationship was marginally non-significant. These relationships imply that reproductive senescence may be a contributing factor to the Sihek's low reproductive success. No relationship was found between age difference and fertility, and no significant effect found between any of the age variables and hatching success. These results are in agreement with other studies on similar species. Relationships between parental age and reproductive success are well documented in birds, appearing in many forms. Sometimes a quadratic relationship is found, with an initial increase in success followed by a reduction over the organism's lifetime, as can be found in the once critically endangered whooping crane. Although a quadratic term was included for dam age in my models, I did not find it to be significant. Instead, my results simply imply a decline in fertility over time. Sihek are bred from the age of 1 year, after which my results suggest that fertility begins to decline. I didn't find any relationship between age difference and fertility or hatching success, in contrast to some studies of other birds. In pied flycatchers, for example, age difference affects reproductive success, such that pairs consisting of older females and yearling males have a lower reproductive success, thought to be due to younger birds taking advantage of the experience of older females by not contributing as much to the nest. My dataset only contained one pair containing a yearling male, so this relationship would require more data to explore. Finally, I tested whether laying order, closely linked with management strategy, may affect Sihek reproductive success. Clutches can be manipulated to encourage birds to lay extra eggs within a clutch or lay extra clutches across a season. In order to determine whether current management strategies were working, I investigated both. Egg position across season was split into 3 categories. Sihek were thought to lay 1 to 4 eggs per season in the wild, so I grouped these into a natural category. The Sihek species survival plan recommends pairs produce a maximum of 9 eggs, so the 5th to 9th eggs were grouped into a recommended category. Any eggs laid beyond this were grouped into a surplus category. Once more, I used GLMMs to investigate the effects of both within clutch and across season sequence on fertility and hatching success, with pair ID and management stage accounting for individual quality and changes in management across time. Model selection and averaging were then carried out once more. In this case, my results found no significant effect of either within clutch or across season position on either fertility or hatching success, although a decline can be seen in fertility past the second egg in the clutch and eggs laid past the breeding recommendations. No significant relationship was found between egg position and either sequence or hatching success. Although investment can differ between eggs in a clutch, this tends to happen in species that lay more eggs in a clutch than the Sihek's 2 to 3. Egg composition across eggs is known to be variable, but this doesn't always affect the actual success of the egg. Furthermore, success across a season can be linked to time of lay in many birds, with evidence suggesting that eggs laid later in the season may fail due to harsher conditions. This rule is less applicable in captivity because birds are provided with mostly the same environment year-round. In captive populations, however, egg success may decline due to female exhaustion. Some evidence has been found to suggest that laying more eggs than they naturally would in one season may negatively affect a female's long-term health and reproductive success. So in summary, I find extremely low fertility and hatching rates in the Sihek. My results suggest that sire inbreeding coefficient and parent age might be contributing factors to these low rates. However, no significant relationship was found between lay order and fertility either within clutch or across season, although a general decline in fertility can be seen in later laid eggs. Furthermore, no significant effect was found between any of my variables and hatching success. This may be due to the smaller sample size used in hatching success analysis compared to fertility analysis. Since I conducted hatching success analysis using only fertile eggs, just 134 eggs were actually available to explore the effects. Any relationship between age, inbreeding, or laying order and hatching success may require more data to explore. Other avenues that may benefit from extra exploration include environmental factors. A study in similar kingfishers found that increasing the temperature of enclosures may improve reproductive success. When studying the extinct in the wild Hawaiian crow, a recent study found that inter-aviary distance was an important factor, with pairs further apart having higher success. Furthermore, evidence has been found in birds that suggest bond length and female choice may impact reproductive output. Females that have been bonded for longer have higher reproductive success, and females that have chosen mates invest more in their offspring. Finally, hand rearing and artificial incubation can have an effect on hatching success and offspring survival, with eggs in other endangered species such as the whooping crane having higher hatching success if eggs have been parent incubated. Understanding how these factors affect reproductive success in the Sihek may well also help us understand some ways we can better manage the ex situ population. So in conclusion, ex situ management can be used to help highly endangered species recover. Higher reproductive success is required to support harvests for re-release, though this is often a problem in extinct in the wild species. It's a very big problem for the Sihek, which has exceptionally low fertility and hatching success rates. This could be in part due to sire inbreeding coefficient being negatively related to fertility. Furthermore, parental age may also play a role. The results found here can provide recommendations for Sihek management. In order to improve the reproductive success of Sihek, management should prioritise males with lower inbreeding coefficients for breeding, as well as younger individuals. Furthermore, although without a significant effect, the lack of fertility in eggs laid after position 8 to 9 in a season suggests it may not be worth pushing females to lay them. These recommendations may contribute to decisions made surrounding Sihek management, helping improve reproductive success and preventing the Sihek becoming yet another extinction statistic, because the world could definitely do with more of these.